Hi! This instructional video is about sum of geometric series. Geometric series. Taking a bunch of geometric sequences and adding them up. And we just find the sum up to a certain point. Students were taking a test the other day and they were stuck on 3 questions. Something very similar to these 3. They came up with an answer, but it just wouldn't match the solution choices. And they said, hey, how far are we supposed to go on these series here? It doesn't say. And you see, they were taught about geometric series. The sum of the geometric series given as s of n is equal to a sub 1 times the quantity of 1 minus the common ratio raised to the n power, whichever term it is, divided by 1 minus the r. And to do that, we have to use the rule of geometric sequences, which was, the general rule was a sub n is equal to a sub 1 times the common ratio raised to the n minus the 1. So we have to use this and plug in what we know about the common ratios to determine the total sum. And we had to do that by being given what term. And since we couldn't figure out, we even thought about using the arithmetic, the sum of the arithmetic series, which is s of n is equal to the nth term times the a sub 1 plus the a sub n, whichever term that is, divided by the 2. It's the mean of the first one and whichever term it is added together. And to do that, we have to use the rule of arithmetic sequences, which was a sub n is equal to a sub 1 plus the quantity of n minus the 1 times the common difference d. So we learned about that, but nothing would work. Then I found out there was an error on the test generator that I used. You see, what we had to use for this, since there was no nth term given, we had to use a thing called infinite. You see, these are all finite. It goes for a certain amount of term, and we had to be given which term, up to what term do we add it up to. But if it's infinite, they don't have to tell us what n it is. And the infinite geometric series, the general rule is the sum s is equal to, and there's no more n because we don't need it anymore. It's infinite. Is equal to a sub 1, the first term of the series, divided by 1 minus the common ratio r. That's it. If the students see these videos, they're going to throw pencils at me, among many things. So let's use this general form for the sum of the infinite geometric series to find out what would happen if you just kept on going at this common ratio. There is a ratio. So let's go and find that. The common ratio is determined by taking the following term, so in this case a sub 2 divided by the initial a sub 1. So you go negative 6 divided by 24. So the common ratio is going to be negative 1 over 4. So it's going to be multiples of negative 1/4. Negative 1/4 times 24 is negative 6. Negative 6 times negative 1/4 is positive 3 over 2. And the a sub 1, the initial term, is 24. And that's all we need to use our infinite geometric series. So s is equal to a sub 1 over 1 minus dr. The initial term in this series is 24, divided by 1 minus the quotient negative 1/4. So if we put this in a non-quotient within a quotient term, wouldn't that be just like saying 24 over, well, that's 4 over 4 plus 1 over 4, which is 5 over 4? And isn't that same thing as saying 24 times 4/5? And if you multiply across, what is that? 4 times 4 is 16. 8 plus the 1 is 96 over 5. So if we kept on adding all these numbers, it will plateau out. It's getting closer and closer to this number, 96 over 5. So like a limit. It's reaching this certain point. And it'll taper off as it gets closer to 96 over 5. Now you could try numbers 2 and 3. And this time, hopefully my students will get it. Okay, so you said, okay, the common ratio now. The r is the second term of the series divided by the first one. So in this case, it's negative 2 over 4. And that's going to be negative 1/2. By the way, there is a condition about using this infinite series. And the rule is this: the common ratio, the absolute value of it, must be less than 1. It must always be a quotient less than 1. So it could be negative or positive, but the absolute value of it must be less than 1. Otherwise, it is not a geometric sequence, or geometric series, that is. So that's the condition it must be. If and only if. Yeah, so that's the fine print. Here we go. So the initial number on this given series is 4. So once again, we use the sum of the infinite geometric series is s is equal to a sub 1 over 1 minus dr. The a sub 1, the initial number of the series, is 4 over 1 minus the common ratio is negative 1/2. So that's like saying 4 over, now this is going to be 2 over 2 plus 1 over 2, which is 3 over 2. And then that could be written as 4 times 2/3 reciprocal. So in this case, it becomes 8/3. So if that's what you got, yep, you got the idea. It gets easier and easier. Check this one out now. Did you do it yet? Alright, so you said the common ratio is, again, the second term divided by the initial term. So we got negative 4 over 12, which reduces to negative 1/3. The initial number on this series is 12. So once again, the infinite geometric series, the sum is a sub 1 over 1 minus dr. So that's going to be 12 over 1 minus negative 1/3, which is like saying 12 over, what is that again? 3/3 plus 1/3 is 4/3. Hey, check this one out. That's like saying 12 times 3 over 4. Simplify the denominator with the numerator. That's simply 9. And that looks very close to what we have for a test question. I hope you guys are not so mad. All right, let's get those done now. See ya.